Hello and welcome to Algebra 2, Lesson 74. In this lesson, we're going to look at some additional graphs of functions. So a few lessons ago, we learned about graphing parabolas. Now, in that lesson, we talked about the quadratic function f of x equals x squared, and then we compared other functions to that, and we talked about the fact that we could have a vertical, a horizontal, or both a vertical and a horizontal shift. So what we're going to do today is we're going to look at some other commonly occurring functions, things that you'll see in Algebra 1 and Algebra 2, and we're going to talk about what creates this vertical and horizontal shift, and we'll talk about how you can determine if you have a vertical or horizontal shift without actually looking at the graph or pulling out a t-table or anything like that. There's a very easy formula to follow. So the first one we're going to look at is the absolute value function. We have f of x equals the absolute value of x. When we talk about this function, the domain is any real number. So I can plug anything I'd like in for x there. I can do a negative, a positive, 0, whatever I'd like. The range is limited though. Remember, the absolute value operation returns a positive if I plugged in a negative. So if I did something like the absolute value of -5, that would give me an answer of +5. If I did 0, I would get 0 back. If I did a positive, I would get a positive back. So your range is limited. The smallest it can be is 0. The largest it can be is positive infinity. So basically 0 or any positive real number. Now, one interesting thing with the absolute value operation, every number except for 0 has an opposite. So 5 and -5, 3 and -3, 2 million and -2 million. Opposites have the exact same absolute value because, again, they're the same distance from 0 on the number line. So what happens is you end up with a V shape when you graph this guy. In other words, if I was to look for points here, for everything I plug in, so if I plugged in a -6 there, I know my Y value, once I evaluate the absolute value of -6, I would get +6. Well, then I could do an X value of 6 there, and I would also get a Y value of 6. So if I look at my coordinate plane, for an X value of -6, I'd have a Y value of 6, but also for an X value of +6, I'd have a Y value of 6. So this guy corresponds to here and here. And what's going to happen is if I did an X value of 5, I would get a Y value of 5, but an X value of -5 would give me a Y value of 5. So this keeps going down like this, and it creates a V shape as it comes back up here. If you plugged in a 2 for x, absolute value of 2 would give me 2. But if I plugged in a -2 for x, the absolute value of -2 would give me 2. So let's graph this guy. Okay. So this is f of x is equal to the absolute value of x. All right, let's talk a little bit about horizontal shifts. And I'll give you a little shortcut here on how to tell if you have a horizontal shift and what the amount of the shift is in which direction. And then in the example we'll get to in a second, I'll show you why it actually happens. So if you see f of x equals the absolute value of x, and then you come across f of x equals the absolute value of x minus h, the first thing you need to understand is that this minus h here happens inside of the absolute value bars. So we would say it happens inside of the function. So you want to write down in your notes that if it happens inside of the function, you will have a horizontal shift. The way you can tell, your operation there is the absolute value operation. So if it happens inside of that, you're going to end up with a horizontal shift. If it happens outside of it, so if you had f of x equals the absolute value of x, let's say +2, this is outside of it. So this will be a vertical shift, but in this case, it's happening inside. So inside of the function. One way to tell for sure is to ask yourself, can I take this guy right here and plug it in for x in the original function, the one I'm comparing it to? Would I get the same thing? The answer is yes, I would end up with this guy exactly. So it is happening inside the function, we've established that. Now, if you have something in this format, the horizontal shift will be as follows. We say if h is greater than 0, we would shift h units to the right. So if I saw f of x is equal to the absolute value of x minus 7, this would mean that I'm shifting 7 units right. All right, the other scenario, if we have f of x equals the absolute value of x plus h, Here, if h is greater than 0, we're going to shift h units left. So f of x is equal to the absolute value of x plus 7 in this case. Here, 7 is greater than 0, so we would be shifting 7 units left. Now let's think about why this is the case. Let's say, again, compared to f of x equals the absolute value of x, we look at f of x equals the absolute value of x minus 3. The shift, according to what I just told you, because this is a minus 3 here inside the absolute value operation, would be 3 units to the right. So this shifts 3 units right. Now, why is that the case? Again, most of you will probably say it's a minus 3. On the x-axis, if we're thinking about that, a minus 3 would be 3 units to the left. So why is this guy saying 3 units to the right? What ends up happening is, for a given y value, a given vertical value on the coordinate plane, x now has to be 3 units larger to produce that. So let me show you with the t-table. Let's say in the original function, I choose an x value of negative 3, I choose an x value of 0, and I choose an x value of positive 3. So the y value here would be 3, the y value here would be 0, and the y value here would be 3. How can I get the same y values over here? Let's just choose them already. So we're going to say 3, 0, and 3 is what we want. Well, I would have to plug in an x value that's 3 units larger than these over here to compensate for this minus 3 here. So in other words, if I had a 0, which is 3 units larger than negative 3, the absolute value of negative 3 would give me 3. So you see how once I take away 3, I'm right back to this guy right here, and then I'm taking my absolute value. So I'm just kind of thinking about what amount would I have to put in there to kind of undo this operation of subtracting away 3, and that would give me the same result as I would have gotten if there was nothing done to it. Okay, so in this case, I have to add 3 to undo the minus 3. That's all I'm doing. So in this case right here, if we have 0, we'd add 3. This would be 3. 3 minus 3 would give me 0. Absolute value of 0 is 0. And then in this case, if it's 3, it would go to 6. 6 minus 3 is 3. Absolute value of 3 is 3. So that's all we're really doing. We're adding 3 to each x value to undo the effect of this minus 3 here. So if we looked at a graph, so we did f of x equals the absolute value of x minus 3. Some points we looked at so far were 0, 3, 3, 0, and 6, 3. So 0, 3 is going to be right here. Then 3, 0 is going to be right here. And 6, 3 is going to be right here. So all we're really doing is shifting everything to the right 3 units. So this would go 3 units to the right. That's my point. I could take this point right here and go 1, 2, 3 units to the right. That would be my point. I could take this guy 1, 2, 3 units to the right. That's my point. 1, 2, 3 units to the right. I already have it. 1, 2, 3 units to the right. You know, so on and so forth. It's the same thing with these points over here. So I could take this one and go 1, 2, 3 units to the right. This one 1, 2, 3 units to the right. You know, so on and so forth. So this guy, let me label it. This is f of x equals the absolute value of x minus 3. Again, for a given y value, the x value now has to be 3 units larger. And so that creates a graph that's just going to shift to the right by 3 units. So hopefully that makes some sense for you. Again, a lot of people think that minus 3 would cause you to go to the left by 3, but it's the opposite of that. You want to go to the right because you're trying to undo the minus 3. So you basically have to think about it as I'm adding 3. So I'm going to the right by 3 units. All right, so what if I saw f of x equals the absolute value of x? And compared to that, I have f of x equals the absolute value of x plus 4. Well, in this case, I'm adding 4. So again, if I just think about it simply, what do I need to do to undo the addition of 4? I would subtract 4. So that means I'm shifting 4 units to the left. So I shift, or we could say shifts 4 units left, right? Pretty easy. So I have this guy drawn already for us. Here's the original, and then here's the other guy where we have f of x plus 4. you can see every point has just moved 4 units to the left. And again, that's to compensate for the fact that we're adding 4 to x. So for example, if I have f of x equals the absolute value of x plus 4, to get a y value of 0, I now have to plug in an x value of -4 to undo that plus 4 there. -4 plus 4 would be 0. Absolute value will give me 0. So to get a y value of 0 now, my x value has to be -4, whereas before my x value was 0. So everything just shifts 4 units to the left to compensate for that plus 4 that's inside the absolute value operation. All right, so the next thing we want to talk about would be a vertical shift. So if we're looking again at f of x equals the absolute value of x, and we see f of x equals the absolute value of x plus k, well now what's going to happen is for a given x value, I plug something in for x, I take the absolute value, everything is the same. But then I have this plus k that gets tacked on to the operation. So my f of x or my y value will change based on this. So this is going to directly affect y. And when we affect y, we're affecting the vertical axis. So we're going to shift up or we're going to shift down. So if k is greater than 0, meaning I had something like f of x equals the absolute value of x plus, let's say, 3. Well, in this case, k is greater than 0. We would just say that we're shifting up by 3 units. In the case where k is negative, so let's say this was plus -3, well, in this case, we're going to shift the absolute value of k units down. So the absolute value of -3 is 3. We'd say we'd shift 3 units down. Now, no one would ever write it like this. This is just how it is presented in your textbook. In most cases, you just see -3 here. So you would just kind of adapt and say, okay, I know if I'm subtracting away 3, I go down 3. If I add 3, I know I'm going up by 3. All right, let's take a look at an example. So we have f of x equals the absolute value of x minus 5. And we have f of x equals the absolute value of x. So we can say for a given x value, the y value that will be produced will be 5 units less. And this will create a vertical shift down by 5 units. So again, we can go with -3, 0, and 3. This would give me 3, 0, and 3. For this guy, if we have -3, 0, and 3, again, I plug in a -3 here. I take the absolute value, I get this result, but then I just get -5. So I can basically take these values and subtract away 5 and give myself the y value from over here. So 3 minus 5 would be -2. 0 minus 5 would be -5. 3 minus 5 would be, again, -2. So I can take these points and plot them. So we have f of x equals the absolute value of x minus 5. Our first point, we have -3 comma -2. We have 0 comma -5. And then we had 3 comma -2. So -3, -2. It's right there. We have 0 comma -5. And we have 3 comma -2. So 3, -2. Now, I can just take points from this original guy and shift them down 5 units if I want more. So I can take this point and go down 1, 2, 3, 4, 5. I can take this point and go down 1, 2, 3, 4, 5. And you can see where the line is going. This right here would be the lowest point on the graph. We know that, right? Because if x is 0, that's the lowest I can make this guy, because the absolute value operation, if you plug in a 0, you get 0. If I plugged in something negative, remember, I'd get a positive. So the lowest I can get is if x is 0. That gives me a y value of -5. Over here, if I shift some of these down, if I take this guy and go down 1, 2, 3, 4, 5. Over here, 1, 2, 3, 4, 5. And I have enough points to get a good graph going. Okay, so this would be my graph for f of x equals the absolute value of x minus 5. So again, every point on the original is just shifted down 5 units. So this went down 1, 2, 3, 4, 5. This one went down 1, 2, 3, 4, 5. This one went down 1, 2, 3, 4, 5. You know, so on and so forth. So in this next example, we see f of x equals the absolute value of x plus 2. So now I'm adding 2 outside of the absolute value operation. So again, I'm just shifting the graph up by 2 units. So we can say this shifts 2 units up. So here's all 3 of these guys. Here's the original. Here's the guy that was shifted 5 units down, and here's the guy that shifted 2 units up. Right, so if I plugged in a 0 for x, obviously you would get 2 for y, right? Because you have f of x equals the absolute value of x plus 2. So you get a 0 there. 0 plus 2 would give you 2. So everything is just shifted up 2 units as we would expect. So what happens if they throw both of these on you? So in other words, you get a horizontal and a vertical shift. This part right here happens inside the absolute value operation. This part right here happens outside. So this will create a horizontal shift, and this will create a vertical shift. You just have to remember inside the function or inside the operation is giving you a horizontal shift, outside is giving you a vertical. So with a vertical shift, it's intuitive. So if you're adding something, you're going up. With a horizontal shift, it's counterintuitive. If I'm subtracting, I'm going to the right. So if I have x minus 1 here, again, I've got to think about what can I do to counteract that minus 1. How can I get this back to where it was? I've got to add 1, so I'm shifting to the right. So this shifts right by 1 unit, and it's going to go up by 3. Up by 3 units. So here's a graph of, again, the original. Here's a graph of the guy that shifted. So it went up 1, 2, 3, and to the right 1. So there's your new lowest point. And you can take any given point and go up 3 units into the right 1. You'll be on the new graph. So you'll go up 1, 2, 3 to the right 1. You can take this point and go up 1, 2, 3 to the right 1. So on and so forth. All right, the next function we're going to talk about is the square root function. So we have f of x equals the square root of x. The domain and the range for this guy are both limited. And the reason for that is simple. If I plug something in for x here, I can plug in a 0, square root of 0 is 0. I can plug in a positive, square root of positive will give me a positive. But remember, I can't take the square root of a negative number without involving the imaginary unit or the complex number system. Because we're limiting this to the real number system, we would say our domain is restricted to 0 or anything larger, and the same thing for the range, 0 or anything larger. All right, so if the function we're comparing everything to is, again, f of x equals the square root of x, for f of x equals the square root of x minus 3, this is happening inside the function, inside the square root operation. So if it happens inside the function, we have a horizontal shift, and again, it's going to be counterintuitive. So what do I need to do to cancel out this minus 3 here? I would add 3. So you think about it like that. This is going to shift, or you could say shifts 3 units right. Because again, for a given y value, my x value now has to be 3 units larger to compensate for this minus 3 here. As an example, let's say we looked at one ordered pair. Let's say I plug in a 0 for x. I know I would get a 0 for y. Well, here, to get that y value of 0, what would x have to be? I would have to increase it by 3 units. I would now have to plug in a 3 for x. 3 minus 3 would give me 0. Square root of 0 would give me 0. So a 3 for x would now give me a y value of 0, whereas before an x value of 0 would give me that same y value of 0. So I had to increase x by 3 units. And it would be the same thing everywhere. I'm just shifting the original graph 3 units to the right. So if we look at the graph, here's the original, here's the one that we looked at after. So everything is just moving 3 units to the right. Here's another point here. This goes 3 units to the right, so on and so forth. All right, let's take a look at some more here. So we have f of x equals the square root of x plus 5, then plus 2. So you have 2 different things going on. You have something inside the function and something outside the function. So inside the function, you have plus 5. So again, to undo that adding of 5, I've got to subtract 5 away. So that means I'm going to shift to the left by 5 units. So this shifts left by 5 units. And then I have plus 2 that's happening outside the function. That would just drive up my y value by 2 for a given x value. So this would cause it to shift up by 2 units. So and up by 2 units. Then we have f of x equals the square root of x minus 7. This is happening outside the function, outside the square root operation. So we can just say this shifts down by 7 units. So this shifts down by 7 units. So here's all your graphs drawn if you wanted to look at them. Here's your original. Here's the one that was shifted down by 7 units. Here's the one that was shifted to the right 3 units. And this guy had both changes, right? It was shifting horizontally and vertically. So it went up 1, 2 units, and it went to the left 1, 2, 3, 4, 5 units. All right, the next function we're going to look at is known as the reciprocal function. So we have f of x equals 1 over x. The domain and range I haven't listed here, but essentially the domain is anything but 0. I can't plug in a 0 because I don't want to divide by 0. And my range is also anything but 0. So any number in the real number system you choose other than 0 is allowed. So the first thing we'll compare to it, we have f of x equals 1 over x plus 3. This is happening outside of the function. So if it happens outside the function, it's a vertical shift. In this case, we're just going to move up by 3 units. So we'll say this shifts up by 3 units. For a given x value, you can see the y value would just increase by 3. If in this one I chose an x value of 1, to make it really easy, my y value would be 1, right? Plug in a 1 there, 1 over 1 is 1, so y is 1. In this case, if I chose an x value of 1, my y value, according to this, should be 4. 1 over 1 would be 1. 1 plus 3 gives me 4. So that's what I would have. So every point just shifts up by 3 units. So here's a graph of these guys. You can see if you pick a point like 1, 1 on the original, you can just shift it up by 3 units and you get to it on the other one. So everything is just moved up again by 3 units. What about f of x equals 1 over x plus 2? Again, compared to f of x equals 1 over x. So this part right here is happening inside the function. I could take x plus 2 and plug it in for x. So what happens is that's going to give me a horizontal shift. So if it's plus 2 here, you just think about the fact that I would need to subtract 2 away to bring it back to where it was. I'm thinking about how I can counteract that plus 2 there. So for a given y value, my x value needs to be 2 units smaller to get to it. So I would say this shifts 2 units left. And to prove that to you, again, let's do a little t-table. I know in this guy I could do 1, 1 as a point. Over here, according to what I just said, the x value would now need to be 2 units less. So that would give me an x value of -1. That would produce a y value of +1. And let's try it. If I plugged in a -1 there, -1 plus 2 would give me 1. 1 over 1 is 1. All right, so here's the 2 graphs drawn for you. This is the original. You can see that point right there, 1, 1. And again, it's just shifted 2 units to the left. So there's your new point where you have -1, 1. So every point in that original would just shift 2 units over to give you the new function graph. All right, so the last function I want to cover today is called the greatest integer function. So this guy, f of x equals the greatest integer of x. You might also hear this called the floor function. Now the notation for this guy varies greatly. You might see brackets around x like this. You might see kind of L-shaped brackets like that. You might also see something that looks like this. This is very common. You probably see that in your textbook. It's in the textbook that I'm using to write this lesson. So no matter what you see, it all means the same thing. In your calculator, you'll probably see int and then x like that. All means the same thing. What this denotes is the largest integer that is less than, or equal to x. You got to think about this as it rounds down to the nearest integer. So if you're at an integer value, you stay there. If you're not at an integer value, you're rounding down to the nearest integer. So in the case where you have f of x equals the greatest integer of x, if x is greater than or equal to -1, but less than 0, what's going to happen is your value is going to be -1. So let's say I'm on the number line and I'm somewhere like right here. Let's say I'm at -0.5. If I round down to the nearest integer, I'm going to the left. So going to the left from that point puts me here. That's going to be the largest integer that's less than or equal to -0.5. Okay, so it's very, very tricky if you don't reread the definition over and over and over again. If x is greater than or equal to 0 but less than 1, so let's say it's 0.5 now, well, if I round down, I'm going to get to 0. Okay, so in this case, I'm at 0. And so on and so forth. If x is greater than or equal to 1 and less than 2, so let's say I was at 1.5. 1.5. Well, then I'm rounding down to 1. So I'm always going to round down to the nearest integer. If I'm at an integer itself, so let's say I was at 1. Let's say I plug that in. Well, it's just going to be the integer. It can be equal to that. But if I'm anything less than 1, let's say I'm at, 0.9998. Well, in that case, I've got to round down to 0, right? I'm in this category where x is greater than or equal to 0, but less than 1. If I'm not at 1 exactly, I've got to round down, so I'm going to end up at 0. So for the domain and range, for the domain, I can plug anything I want in for x. There's no restrictions, right? All real numbers. But for my range, remember, if I plug something in here, the output is going to be the largest integer that's less than or equal to the value I plugged in. So I'm limited to just getting integers back. So my range will be the set of integers. So we sometimes refer to the greatest integer function as a step function because of the shape of the graph. And the way it looks kind of like that is because for a range of x values, you now have the same y value. So for an x value that is greater than or equal to -3, but less than -2, we know y would be equal to -3. If x was greater than or equal to -2, but less than -1, we know y would be -2. If x was greater than or equal to -1, but less than 0, y would be -1. If x was greater than or equal to 0, but less than 1, we know y would be 0. So on and so forth. You'll see the pattern in a minute. Let me do one more of these, and then you'll be able to draw as many as you want. So if x was greater than or equal to 1, but less than 2, y would be 1. So let's just think about this on the coordinate plane here. So again, if x was greater than or equal to -3, but less than -2, y would be -3. So let's find a y value of -3. Let's go over to an x value of -3. I put a bracket here to say this is included here. Then I'm going to draw a horizontal line across. Then at -2, I'll put a parenthesis to say it's not included. Then I'm just going to step up to the next integer for x, and I'm going to do the same thing. I'm going to put a bracket to say -2 is included. I'm going to draw a horizontal line to -1. -1's not included. I'm going to step up again. Put a bracket here, go over to the next integer. Put a parenthesis, step up again, bracket, parenthesis, step up again, bracket, parenthesis, step up again, bracket, parenthesis, step up again. So again, for a given range of x values, there's a set y value. So if x is between -3 and -2, where -3 is included, y is -3. If x is between -2 and -1, -2 included, y is -2. So on and so forth as you go up or as you go down. Now, just as before, we can still have vertical and horizontal shifts. If I have f of x equals the greatest integer of x minus 3, this happens outside the function. So I would just be shifting down by 3 units. So this shifts down 3 units. For this one, f of x equals the greatest integer of x minus 5. This happens inside the function. I could plug x minus 5 in for x, and this is what I'd get. So this is going to shift to the right by 5 units. So this shifts right by 5 units.